Hello, class 11 students. My name is Vaibhav. I'm a physics teacher at 100 Physics Academy. Now, today we are going to learn about a concept called rigid body. So, Newton ने जो physics बनाई थी, he introduced a concept called particle. Even for every motion, he assumed that the whole mass is present at one single particle, and for that particle, we can define only the translation motion. But if let's say type of bigger bodies, this not only moving in a straight line, which is also rotating or a different kind of motion, then we have to understand what is the meaning of the term called body. So what is body? Collection of many particles is called body. So a concept of rigid body we have to understand. As per the Newtonian mechanics, Newton introduced the concept of particle. Even for the motion of Earth around Sun, Earth is such a bigger mass, he assumed that the whole mass is created as a one single particle exactly at the center. So, is this a valid concept? If we say yes, then yes, but partially only as long as a body is moving in a straight line motion or a circular motion. But if we have to consider the motion of Earth on its axis, we cannot consider the motion of Earth on its axis by considering it to be a point mass. So, rigid body. What is a rigid body? Let's a particle moving in a straight line, we can still assume the whole mass is present exactly on its center. But when the body is rotating, then no, it is not a sufficient concept. We have to define the body. How does it actually move in a rotational motion? So, what is a rigid body? Rigid body is a body in which whatever force you exert, the distance between the atoms or the molecules is not going to change. Again, I will repeat. Rigid body is a body which is bigger in size. There are multiple particles. Whatever force you apply, the distance between them is not going to change. So, if you exert a force, this distance remains fixed. That means it is a rigid body and is not one single particle. This is called interatomic distance that remains fixed. And when we exert a force, the whole body as a system moves, but through a condition like a rotation of a fan blade, this does not true because the particle is moving this different kind of motion. So for that, only we have to introduce a concept called rotation motion, and then later on we'll see rolling motion. One particle is say I, other particle is J, the distance between them is fixed. If it is a perfect rigid body, when we apply the force, the distance between them is not going to change. It remains as it is. Both the particles start moving with same velocity. So between them, the relative velocity is zero and the distance is not changing. That means they are a perfectly rigid body. But let's consider the example of rubber. When you stretch a force, apply a force, it gets stretched. Distance within it changes. Now, if a rigid body is rotating, this is the rotation about a fixed axis. Each particle move on a circular path with same angular velocity and same angular acceleration, as in the case of the tire. But you may say that tire is not a perfectly rigid, but we can approximate it. There might be some deformation, otherwise, more or less every particle has same angular velocity, angular acceleration. Same as in the tire, same as in the motion of the blade of fan. If we consider an example of rigid body, the beam of a bridge is made of a very strong material called steel. If a person is walking, there is no deformation. That's an example of rigid body. But yes, maybe a heavy mass like a truck can, a little bit shape changes, but when it goes, again, it comes back to the original shape. That is a property called elasticity that we will see in the later chapter. So bridge is made up of steel girder, which is a kind of a perfectly rigid body. There's not much deformation even when traffic moves on it. So rigid body, now let's say an example of non-rigid. Our muscles are non-rigid. We apply force, it becomes soft, it moves. Spring is a non-rigid system. When we apply force, it changes. But on a perfectly rigid body, when you apply a force, each particle move with same velocity, same direction. So the distance between them is not going to change. Translation motion means every particle has same velocity, same direction. They move in the same path. They have the same parallel velocity. That's why the distance between them is rigidly fixed. This is an example of translation motion. So rigid body only translate when you apply a force. and about an axis, every particle rotates. So the concept of point mass is not sufficient to explain the concept of rotation motion of a body like a spinning of Earth on its axis. So that's why we will introduce this concept in the next few lectures. Then we'll see what is the pure rotation and what is the pure rolling motion. Thank you.